Hey, what's up, guys? What's going on, man? Hey, this evening, man, I just wanted to do a quick video going over the practice for you because we're going to have this quiz. So we're going to actually call this the 1.5 worksheet, okay, because it covers everything we did. This first set of directions says write each expression in radical form or write each radical in exponential form. All right, so right here, this is an exponent. So we're going to write it in radical form. All right, remember. All right, matter of fact, hold on one second. All right, right here, guys. Remember, for radical, this is your index. All right, if it was a fraction, all right, if this was an exponent, this would be your denominator. All right, this will be your denominator, okay? Matter of fact, I tell you what, guys, this is your index, this is your radicand. You will have a power up here, all right, some power, okay? If you were to rewrite this radical, all right, index and a power, and you wanted to convert it to an exponential, remember, your index, you have your radicand, your index is the denominator, and your power is the numerator, okay? All right, so make sure you remember this. This is from 1/4. All right, that looks like an R now. Let's try this. There we go, power, index, A to the P over N. All right, remember, your power is your numerator. Your index is your denominator of the exponent, okay? So now let's go back and look at number 1. Number 1, write each expression as a radical. All right, well, if we write this as a radical, all right, again, the denominator is our index, and the top is our power. All right, so when we rewrite this as a radical, our index is going to be 3, our radicand is 5, and the power is 1. So you have the cube root of 5. Over here, again, this is the index. All right, this is the index. So you have the 5th root. Our radicand is 6. Our power is 2. All right. I'm going to leave those two for you, okay? I'm going to leave those two for you. Down here, we have a radical. All right. Now, with the radical, we need to rewrite the radical as an exponent. All right, so if you remember the rule, our index right here is not written. All right, so remember there's an implied 2 there. There's an implied 2 there. So, with that being said, our index would be 2, and the power, there's an implied 1 right there, 79 to the 1st. So when you solve this and write it as an exponent, because it's write radicals as exponents, you get 79 raised to the 1/2, okay? Right here, let me go ahead and jump to this one. Well, no, let's do this one. Right here, the index is 4. So you have 153 raised to the 1/4, because again, that power right there is 1. Over here, all right, again, just look at it. This whole thing right here, all right, is the radicand, okay? So understand this. If I had the cube root of x, right, well, I would rewrite this as x to the 1/3. So again, this whole thing is my radicand. So I'm going to write it as 7m to the 5th, n to the 4th, raised to the 1/3. All right. Again, this whole thing is the radicand. This whole entire deal right here. All right. So now, remember the rule from class today. Let me go to my other one. Well, you have a power to a power right here. Power to a power. What do you do with those? A power to a power tells us we multiply the powers. All right, we multiply the powers. So, right here, the 7, all right, there's one term. Everything gets, matter of fact, here, let's go back to our rules. before we address the power of the power. Right here, see how there's different terms? Just like in that problem, there's different terms where everything in that, the m, the exponent is distributed to everything in the parentheses. All right? So right here, we're going to distribute the 1/3 to everything here. So you get 7 to the 1/3 times m to the 5th to the 1/3 times n to the 4th to the 1/3. Okay? Everything gets the 1/3. Okay? Everything gets that power. Now, last thing, we got to address the power to a power. All right, this one stays. That is just 7 to the 1/3. Remember, we're writing it. Remember, it was radical form. We're writing it in exponential form. Okay. So we have 7 to the 1/3. It's in exponential form. All right, but right here you have a power to a power. Well, look at the rule. Power to a power. You multiply the powers. See, power to a power. Multiply the powers. So you have 5 times 1/3. 5 times 1/3. Remember, you multiply the whole number straight to the numerator. All right. So when you do that, you get 7 to the 1/3. Now, the power to the power, 5 times 1/3, 5 times 1 divided by 3 is going to be m to the 5/3. And you have n, 4 times 1, 4 thirds. All right, there you go. All right, so to rewrite this in exponential form, here you go. 7 to the 1/3, m to the 5/3, n to the 4/3. That's exponential form, excuse me. All right, so again, I'm going to leave this right here for y'all. Number 8, get at a shot. All right. Down here, evaluate each expression. All right, evaluate each expression. Again, man, you can literally do these in your calculator. All right, or just show work. All right, show work. Okay. So evaluate this expression, 81 to the 1/4, guys. All right, you can rewrite this, and I'm going to practice rewriting this. I think y'all should rewrite all these in the opposite form. Right, this is radical. Put in an exponential just so you can have practice. All right, and then I want to show you a little technique. Okay, for this one, all right, 81 to the 1/4. If I rewrite this, remember that becomes my radical. I mean, that becomes that's my index. It becomes my radical. So I have the 4th root. If y'all hear my baby, man, he's sitting right here. I'm going to show y'all. This jug is hanging out. That's my baby. And that's my other one. That's Joe, y'all. All right, anyway. Yeah, there's nothing left. You ate it all, fat boy. Here. Good night. All right. So right here, you have 81, all right, to the power of 1. So look, I'm going to show y'all this really simple technique, man, that'll actually help you solve this. Let's say you don't have a calculator. I want you to take 81 and think about this, okay? You can do this in a calculator, all right? But from showing your work standpoint, 81. All right? Oh, what do you think the lowest possible prime number is? All right? The smallest prime number that would go into this 81 would be 3. All right? So if I take 81 and divide by 3, I'm going to get 27. And 27 divided by 3 is going to be 9. And 9 divided by 3 is going to be 3. And 3 divided by 3 would be 1, okay? So now, you got to ask yourself, see how this index right here is 4? All right, come on. See how the index, hey, grab that. See how the index is 4? All right. Well, I need 4 3s, all right, because the index right here is 4. All right, so here are my 4 3s right here. 1, 2, 3, 4. All right, so after I highlight these, what's left? Just 1. All right, just 1. So basically, I got my 4 3s, so the answer is 3. All right, there's no radical left over. All right, so the answer is 3. All right, Now, I know you guys are like, man, I don't get it. I don't get it. Let me show you another example so you can get it, okay? Over here, this example, all right, 1024, the fifth root, all right. If you look at this, is a positive number, right? 24 is a positive number. So, of course, the smallest prime number is 2. All right, so again, if I start with 2, and then if I go 1024 divided by 2, all right, and that's going to be, all right, and that gives you 512. Now, 512, that's divisible by 2. All right, so 512 divided by 2 is going to be 256, all right? And if I divide that by 2, I'm going to get 128. And if I divide that by 2, I'm going to get 64. If I divide that by 2, oh my gosh, man, relax. I'm going to get 32. It's 32, sorry. I put 22. So we take 32 and divide that by 2. That's 16. All right. Hold on, let me write that so y'all can see it. 16. No, like that. All right. And then we take that and divide by 2. I know it seems like a lot, guys, but bear with me. Divide that by 2, you're going to get 8, and divide that by 2, you get 4, and divide that by 2, you get 2. All right. And if you divide 2 by 2, you get 1. All right. So there we go. We went all the way up. Now check this out, guys. I'm about to show you how this works. All right. What I did right here is I highlighted 1, 2, 3, 4, 5. All right. 5. All right. The index is 5. I highlighted 5 2s. So that's a 2. All right. Oops, still on the highlighter. Hold on. 5 2s. So I pull out a 2. Now, again, 1, 2, 3, 4, 5. 5 2s. All right. There's 5 more 2s. All right. So I'm going to use those as well. 5 2s. And the reason I'm going 5 2s again is because that tells me that this fits that index. All right. So 5 2s, which means there's another 2. Okay. Now, what's remaining? 1. All right. 1. So, again, if it's just 1, and when you think about it, it's like having the fifth root of 1. All right. So if it's just 1 remaining, don't worry about it. So 2 times 2 is 4. All right. So the fifth root of 1024, guys, is 4. All right. I'm just showing you a way to do it, man, by hand. Okay. Again, this one right here, this one you would evaluate. All right, because again, it says evaluate. All right, evaluate. So if I evaluate this, all right, a couple different ways to do it. I will rewrite it. Remember, this is your, this right here, that 3 is your index. So the cube root of 8 to the 5th. All right. Now we need to evaluate it. Okay. So now there's a couple different ways you can do it. First, you can evaluate the cube root of 8. All right, and then raise to the 5th. All right, if you do that, the cube root of 8 is 2. And then you have 2 to the 5th because the 5 is still there. So 2 to the 5th, guys, will give you 32. All right. Or you can do 8 to the 5th. All right, like this. All right. If you do 8 to the 5th, you get a really large number like 32,768. And then you'd have to take the cube root of that. All right. And the cube root of that is 32. All right. So there's a couple different ways to do it. You know what I'm saying? But the main thing is you get the right answer. So the answer right here is 32. All right. 32. I'll let y'all have it those. Okay. I just wanted to explain it a little bit. Let's see. That's those. Let me make sure I got them all. All right, these, simplify. All right, simplify. All right, again, this one, 256. If you think about it, see that's even. All right, don't forget this negative. I'm going to come back to this. But for right now, I'm going to do it by hand real quick. So this is a 6. All right. So I have 256. If I divide that by 2, the lowest prime number I know of is 2. So that's going to be 128. If I divide that by 2, 64. If I divide that by 2, 32. Divide that by 2, 16. Divide that by 2, 8. Divide that by 2, you get 4. Divide that by 2, you get 2. Divide that by 2, you get 1. Alright? So now, the index is 4. Alright, 4. 4. Alright? So with that being said, I'm going to count my 2's, okay? So I need 4 2's. So here's 4 right there. Get back to 1. And then here's 4 more 2's, right? 1, 2, 3, 4. So I got 2 sets of 2's, which means 1, 2 fits. One of the 2's work. And I got 4 more, so the next 2 works. Alright, then I just have 1. So 2 times 2 is 4. Alright, 2 times 2 is 4. But don't forget this negative. The answer to the 4th root of negative 256 is going to be negative 4. Alright, well, the negative out here. So the square root of this, you get negative 4, okay, so 17. Alright, and lastly, man, I'm going to jump to something like this. Alright, first off, if it was me, I would rewrite all these. Alright, I would rewrite this in exponential form. I would go 216 to the 1/3 times p to the 1/3 times q. Oh, I'm not p to the 1/3, I'm sorry. Times p cubed to the 1/3. And again, all I did was I just rewrote this in exponential form. Remember, that's your index. That becomes your denominator. So again, if I had the cube root of x, it would become x to the 1/3. Well, again, all this is the radicand. Like, that's the radicand, and it goes to the 1/3. All this goes to the 1/3. So q to the 9th to the 1/3. Alright, dude. So now, when you look at this problem, 216 to the 1/3. Alright. 6 times 6 is 36 times 6 is 216. So this right here, that's 6. Now this, remember, power to a power, you multiply. So 3 times 1/3. Alright, 3 times 1 is 3. 3 over 3 is 1. So P. Right here, 9 times 1 is 9. 9 divided by 3 is 3. Alright, so this answer right here would be 6PQQ. Alright. So, just a short video, man, trying to help you guys out. Seriously, man, I hope this helps, man. Alright, practice. You gotta practice. The only way you're gonna pass the quiz, okay?